Hello and welcome to my YouTube channel. If you're just being here for the first time, my name is Henry Barnabas and I'm a project engineer, highway designs. I've been designing highway infrastructures with Civil 3D for a couple of years now. And in this video, I'm going to be teaching you how to remotely source survey data of anywhere on the surface of the earth remotely with your computer. Okay, a lot of you have been requesting for this, having watched my previous video and wanting to practice further, but you don't have survey data that will enable you to help yourself improve. In light of that, actually, I want to start by actually appreciating you all for watching the first video and also the second video I've uploaded on this channel. If you haven't watched that, you should go and watch it. It's a comprehensive webinar I made on using Civil 3D to design a highway. Okay, so a lot of you have engaged with it and commented. Some have come to my inbox to show their appreciations. It really means a lot to me. Thank you so much for the feedback. And some of you have been recommending things that I should teach and further like that. Yeah, with time I'm going to continue updating this channel as I get the chance to. So some of you are in my paid class, which if you're interested, you can always message me. Yeah. So in this video particularly, like I said, I'm going to be teaching you how to extract survey data from your computer remotely, so you can use to practice from any road. You can use to practice the design of any road. Okay, so let's get into the video. By the way, you are going to be needing two tools in doing this. Okay, you would need your Google Earth Pro, that is installed on your computer. You can download that free from the internet and install it. And then secondly, you will need GlobalMapper. Okay, that's the tool you're going to be using to extract the survey data. So without much ado, let me open my Google Earth Pro. So I'm just going to search for my Earth Pro. Okay, here is it. Okay, it's going to open. Make sure you're connected to the internet so that it can load fast. All right, let's wait for that to open. Okay, great. So it has opened up. As you can see, it will begin to load. This is our Earth. Wow, it's a beautiful round shape. I cannot imagine that there are some people that still believe that the Earth is flat. Don't worry, that's a lighter note. I don't know how they think. Those people are still in the Stone Age probably. So let's go ahead. Now this is of course Africa, and we have so many places around the world. They say like our Earth is like 75% water. Is that true? I think that's what geography tells us. But somebody asked the question, then what is under the water? It's land. So how can we say so I guess what is true is that the surface area of the Earth is 75% covered by water. If not, if it is the entire mass, I don't think it's true, because under the water is land. All right, that's not what we came for. So now let's look for a place on this surface of the earth, anywhere in this map. I'm a Nigerian, so I'm going to look for somewhere in Nigeria. I know I have so many people from different countries, Uganda, even other continents. Yeah, just anywhere. Find somewhere in your continent. You can be able to extract the survey data from there. So let's search for somewhere in Lagos. Lagos is one of the most population dense states in Nigeria. So let's look for Lagos. I'm just going to come to my search here and type Lagos. As you can see, it will zoom me into Lagos. Okay, generally this is Lagos. Okay, it's by the Atlantic Ocean, right? Yeah. So it will begin to open up. I'll just use my mouse and be zooming in. Wow, Lagos is quite a very big place. You can see all these are people's houses. My God, very dense, very dense. So let's look for somewhere we want to extract data from. All right, I'm just going to be looking for just anywhere, any free place. Where you want to remotely search. People use this method. This number I'm teaching you is for proposals, design proposals. Okay, because the elevations are not very accurate. It's not very accurate. So because it's something that is taken using satellite image, satellite shuttles or space shuttles rather. and cannot be that 100% accurate. You must need to take your survey data when you want to come and do the final designs. So let's look at this place. Besides, let me off these roads, let me off them so that they won't be showing. So let me assume that this is a random place. It's not like a place I know of. So this is a random place. I want to take the survey data of along this road. Mind you, this thing is going to take the existing ground level, so, and I'm going to just take along this road, just I don't know how many meters that is, and then along this road. So yeah, so let me just get straight to it. Okay, I'm going to use, if you look here, there is what we call path. Okay, there's what we call path. You'll click on it, it will create a new path. Okay, so now we are going to give it a name. Let's say Centerline. I'm going to take the Centerline. This is an existing road. Okay, so you can use it to take and a proposed road, because from your Google Earth you can propose the alignment of the road, because you are seeing the thing from top view. So if it's a new project that they want to design a road connecting one city to another, so, and it's through a virgin road, so you can be able to even do it on Civil 3D, then as do your preliminary extraction of data and stuff like that. So let's go ahead. So in this center line, and now I want to take the center line of these two. Let me assume that these two rows are oh my god, what am I doing? Okay, I'll begin by taking points, okay, along this median. I'll just take the median as center line. I know it's not the center, these are two different routes, so but let me just assume that this is the center line of this road. So I'm going to start, I'm taking it randomly. Okay, I'll just start from here maybe, and then click here. Each of these points I'm clicking represents where the coordinates will be taken. So I will just be clicking randomly. If I want to specify, if I want to be doing it at a specific distance, I can come to these measurements. You can see this is in miles. I'll put it in meters. So I'm seeing right now I'm at 167 meters. So I'll keep clicking. If I want to make it at a specified interval, okay, all I need to do is once I click, I adjust. Okay, you can always adjust it like this. Okay, let me start over. Let me explain to you what I mean. So like here, I've started here. So if I click the next place, if I want to do it at 50 meters, I can see that now I have 43. So I can just shift it to 50 maybe. It must not be accurate, because if you want to be accurate, you keep doing this back and forth. So it's like 50.6 now. Fine, I'll just use that ID and just be clicking. May not be that perfect. I should be at 100 now, but then let me just keep going as you want. If it's 50 meters, if it's 25 meters, anyhow, usually I take at 25 meters or 20 meters. So but just this is for the purpose of demonstration, right? So let's say I'm okay with here, I want to get this, and that's all. So while this center line is I'm still on this one, I can just still do for this road. Let's say this intersecting road. Okay, I'll just come here. Don't mind this line that is coming. It's not taking any elevation at this line, it's taking it at the points. So I'm going to click, okay, along this line. Okay, right? So I've taken something that approximately is the center line of this road. I want to use it and define my distance. Let me add some here. It doesn't matter how I'm jumping and dropping. I know that it's only taking the points at where I am clicking, at where the dots are. So I'm taking some along this part. Fine. Okay. So if I'm done with that, I'm going to press OK. Okay. Then if you come to these places here, it's going to appear here. All right. And then you see it as center line. So center line, and then I'll take some levels around the center line to the right and to the left of center line. So I'm going to start again, click on this, and then create it, call it ground level. Okay, so I'll now just along this center line, I'll just begin to do things like this, random point. Can you see what I'm doing? It looks like, okay, let me make it more organized. Let it not be like a child's play now. Okay, let me do it like this. I'll just do like this. All right, that seems like I'm just taking like a corridor along the proposed road at a very good offset. Okay, so that I'll be getting the levels at those places. Don't mind that I'm clicking on top buildings. This survey GIS that I'm going to be using with GlobalMapper, it's approximating to the level of the land, okay, of the land, not any building that is there. It doesn't matter about it, you don't care about it. All right, so as you can see, let's keep going. Right, I'm not 100% perfect, and you don't have to be. If you want to be measuring it with rulers, good luck, you will spend a lot of time doing it. Okay, so I'm just going to be, so I'll just take some corridor along this road. Cool. This is typically how it's usually done on site, okay, except that of course they will not enter into buildings. They will just take it within the exact corridor of the road and give you for you to import. So let's say I'm okay. I've created two, and they are called Centerline and ground level. So what I'm going to do, I'm going to save them somewhere into my file as KMZ files. So I'm going to right click on the Centerline first, and then do save as, save place as. Okay, then I'm going to come to my folder in documents, and then I'm going to look for a folder. Let me create a new folder there and call it let me call it extract data. Okay, so I called it extract data. Open it up and then save this center line there. Is that okay? So I'll come to ground level, right click on it, and then go to save place as, and then I'll go to, it's already taking me to that folder, and then I'll press OK to save it as a KMZ file. All right, so once I'm done with Google Earth. So I'm going to close it up and then open my GlobalMapper. All right, I will open my GlobalMapper. I'm using GlobalMapper 22.1 64-bit. So I'm going to click on it to open. So I'm going to wait for that to open up. Okay, so yeah, to install the GlobalMapper, you would find it in my Telegram channel, a link to do that. So let's wait for it to open up. Okay, that's wrong. Okay, yeah, it's opened. Great. So once you have your GlobalMapper open, all right, so the first thing is to import these points that you have done, the points into your GlobalMapper. So what you're going to do is, as you can see from here, right here, you can just click on open data files, or you can come here to file and then open data files, depend, or you can even for short press Ctrl O. So many ways to do one thing, right? All right, so let's start from there. Let's start from here. This is the most common. All right, then we are going to look for where we saved it. So let's look for documents, and then under documents, I think we saved it at extract data. Let me type E, extract data, and then I'm going to click on Centerline and then open. Great, look at it. Can you see that? How cool is that? Okay, so once you have done it, the next thing is to load your map. Okay, just make sure you are zoomed to the screen, you put it in the center, and then you load your map. This is to connect to online data. You click on it. Okay, once you click on it, you wait. It's going to open different data source for you. So we have so many data sources. We have Asta GDM, we have SRTM, we have, you know, this and that. So usually I use SRTM. Okay, all right, so SRTM elevations, I found it to be very reasonable. In fact, there was a time I did a particular road that when they now took the real survey data afterwards, SRTM data was almost giving me the same kind of profile. Of course, not perfect, it can never be. So, but it was giving me the same kind of undulation, right, as opposed to when I used Asta GDM. Asta GDM was like maybe something taken a long time ago, or the resolution is not that, you know, good as SRTM. So I'll just click on SRTM and then press connect. So once it's connected, you can see, right, the data has been loaded. But where is my center line? It's because of the order right here in this tray. I can just drag this down. Okay, I'll drag this one up, and then you can see my center line is back fine. All right, so let's have it. Okay, so this is it. Now I'm going to go to tools. On tools, I go to configure. Okay, under configure, I'm going to go to projections. All right, make sure your projection, you may not see it or open at first, but you go to projections, and then under projections you want to change the projection to UTM. Okay, Universal Traverse Mercator. That is the normal coordinate system style we use. So you go to UTM. Once you click on UTM, everything should appear, should upload by itself. So the zone is 31, and then the datum is WGS, and all of this. This zone 31, if you go to your Google Earth, did I close Google Earth that time? Okay, I just shut it down. How I should have just minimized it. That's not good. So let me go to my Google Earth. I want to show you where this 31 also relates to, confirms that we are at the right place. So okay, once I open it, let me go back to my center line. Where's that center line? I'll double click on it and it will just zoom me to that center line. Great. So if you look down here, you will see 31N. Can you see 31N? All right, so that is show you the coordinates. This 31N. I don't know what it's called. So the hemisphere is divided into like 60 latitude zones, 60 zones. So this is zone 31N. So it confirms that we're in the right place, 31. So and then the datum is and all of this. So leave all these things like this and then apply. Okay, once you apply, you press OK. So once that is done, the next thing you are done. I mean, you are really done. So all you need to do is export your survey data. So you right click, you click on File and then go to Export, and then make sure you click Vector LiDAR format. Okay, and then in this option you have to choose XYZ simple ASCII text file. You click on that and press OK. Now all these things you may not need to change anything, because the coordinate separator is comma, which is okay, and then it should start in the order of longitude for X, that is X first, and basically all these things should be, just leave it. You don't need to make any changes that will give you headache tomorrow. All right, let's go with OK, and then it will ask you to save the file. Look for a folder where you save it. So let's look for that same folder where we did the first one. I think it's in extract data. Where is extract data? Let's press E, extract data. Good. So I'm going to call it CL extracted. Fine. So I press save. Cool. Once I'm done with CL, that's all. So I can just come here and then right click and then remove this. How do I remove it? Okay, I'll just close it. I'll close it rather on unload files. So I'll unload the center line. So and then I'll upload the other one. So I'll go to File, open data, and then click on ground level and open it. So it will load the ground level. All right, I can do this for multiple of different type of level, different roads, different areas, and then be doing them one after the other. So exporting them. So I'll click on this and go to export, and then vector LiDAR format again. It will automatically give you give you your last settings. So and press OK, and then here again I'm going to put ground level extracted. All right. So cool. Okay, I'm done. Dada. So I'm going to go, I'll just put them in Excel now. So I'm going to click on documents. I'll go and find out, let me look for extracted data, and then look at it. So CL. Now look at our CL. Can you see? This is our center line. These are the coordinates. All right. So what we can do from here is to put this text in Excel file. All right, so I'm going to copy this text entirely. All right, just the text representing the elevations. I'll press Ctrl C to copy. Then I'll open an Excel blank sheet. Just type Excel and then open a new blank sheet, a workbook. So from here I'm going to just paste it. So as I paste it, it's going to be joined together like this in delimited form by commas. Let me close this. So what I'm just going to do is to go to data, and then and from data I'm going to make sure I click on text to columns. Okay, no data. So I have to select all of this data and then go to text to columns. So these are delimited files, okay, by commas. So I'm going to forward, and they are delimited by what are the delimiters is asking you is comma. So once you say comma, look at the preview. The preview shows that it has been divided into 3 columns. So I'll press next, and then I'll press finish. So what happens now? You can see that these have been divided into X, Y, Z. Cool. So that is how you do it. And remember, this is you can just add a cell before it, insert, and then press 1 2, and then you just drag it to complete to the last. And remember, these are center line, so you can press CL1 and then CL2, and then complete the rest by filling it up. So pretty much this is PENZD, the format that is very ideal for usage in Civil 3D. How cool is that? So I can still go back and then open for ground level, so you can see the point for ground level. So I can just from here right click, I'll press Ctrl Shift End on my laptop so that it will go to the last one without having to keep dragging. You know, I like dragging is a big work for you if there are too many points. So you just press Ctrl C, and then you go to your Excel, and then make sure you start from here and paste it. Ctrl V. Once you paste it, because you have done text to column previously, Excel is generous enough to automatically know that you want to do text to columns and then it will divide it for you. How cool is that? So from here I'm going to just press GL1, and then because it's ground level, GL2. All right, and then complete it. Then this numbering I can just drag it to complete it. How many points were we able to extract? 115 points. We are genius. All right, mind you, I would like to reiterate that these levels, as you can see, they are looking cool. Can't you see? 65, 64, 61. You know, they are cool. But let's why not? Let's try it. Let's try to save this and then import it into Civil 3D and see how it appears. So let's quickly go to File and then Save As. Then let's go to our that folder that extracted data, and then save it. Make sure you save the file type as CSV command delimited. So and then you press let's call it Lagos Road 1. I don't know, whatever we want to call it. So Lagos Road 1 data. So you press enter. So we have saved it as a it's asked to use format here. Yes, got it. So let's close it. So let's go back to our folder. Can you see that? That's the CSV file. We can open it in Civil 3D. Let's try opening it. Let me look for my Civil 3D 2023 metric. Okay. So while waiting for this, I want to emphasize that these levels are not accurate. They're only used for proposals. All right. I've done so many design proposals before doing the final proposal. So most times you may need to do this extract the data remotely. Then it helps you to quickly, at least the alignment will be okay, but the levels you still need to go and take the real data. Why is this so, if you may ask? It is because when you are taking levels, all right, you're not just taking level, you have to set out those levels later on when the road is constructed, it's being constructed. So but you don't have a benchmark if you extracted the data remotely. So but when you have extracted the data, all right, using a survey instrument, either DGPS or total station or whatever instrument, you can be able to, you have a benchmark, all right, which are permanent points that defines locations and elevations. I think I browsed something here. Okay, this is an example of a benchmark. Okay, sometimes they cast it on site on the ground, so these places represent a specific elevations and location. So yeah, that is it. Why is my Civil 3D taking too long to open? It doesn't do that like this always. I mean, so let me just fast forward to when it opens, right? Oh, that I have it open. So let me just close this, and then I'll press new just to open a new sheet. Okay. Okay, so once it opens up, you go to your prospector tab and then go to points, right click on points, create points. And so you can now import points. So let's go to import points. Let's look for our documents, extracted data. Where is it? Extract data. So let's look for Lagos Road 1. Good. So now we go to PENZD, delimited, and look at the preview. Press OK, and when that loads, we can be able to close this and press ZE to zoom extent. Okay, and press enter. Okay, let's see if our point successfully opened. Yeah, cool. Look at it. All right. So I would have gone on to start designing this road already, but I have a video on that already, so you should go and watch it. So I think that brings us to the end of this tutorial. Thank you for joining in, and I hope to see you in subsequent videos. So the caveat, as I always have said, is this is just for you to practice. So there's no limit to what you can do here. In extracting the data, you can extract the data as long as you want, and any way you want. So if you have any question, let me have it in the comment box, and feel free to ask your questions, as I said. And then if you wish to make suggestions on future videos that I should make, I'll be reading your comments. Thank you so much. And if you want to join any of my Telegram groups, it's free. It's also in the description box, and then you can be able to go there. There's a lot of people sharing their questions and others answering, and it's a very interesting place for you to continue growing if you are just starting. So have a nice day. See you in subsequent videos.